Hi, we'll continue our discussion about while loops and files by looking at word processing. And this is a class of methods of programs that you will do in general to process text. So you will have a text given, and then you want to extract some information about that text. And in this program, we look at something very simple. We like to compute the frequency of some words. Now, we read again a text from a file, word by word, and we like to trim the words. We need to trim, I will show you why. And then we like to count the number of words and count how many times some words appear, like the, a, and, and for these words, we like to compute the frequency. The frequency is how frequent they appear in a text, and you just divide the number of, you counted them, so you just divide by the number of words, and you got the frequency. And again, we'll read the text from a file, and we'll need to mark the end of the file, like in the number case, with a special text, and the special text that we will do is this one. Now, let's create the example of this file. Let's create a file that will be text, and in this file, I will just put some Java documentation from the official documentation of Java, and here it's from chapter 4, types, values and variables. Sure, you see it's not wraparound, so let's see how you can wrap around in Eclipse. If you go on Windows Editor, we can toggle the word wraparound, and now you can see more clearly which is the text. And what we want to add to this text is an end symbol, the symbol that will mark the end of the text, because we want to be sure that we identify where our text will end. First thing that we like to do is to read our text and to identify the tokens, that we want to process. And after we identify them, we'll see what other operations we'll need to do. Now, the structure of our program is the following. We'll initialize the computations, like defining the variables that we need and so on. Then we'll read the first word, and while we don't find the end token, we'll repeat to prepare the word. We'll see that we'll need to modify a little bit the word to be able to count it right. Then we'll print both the read token as was read and also the prepared word. We'll process the word doing all the counting that we need, and then we'll read the next token, the next word to, let's put here token, read the first token because the word will be the processed word. And token. So we make this distinction between a word that is processed and the tokens that we read from the file. Then we'll compute the frequency based on the information read, and we are able to print the result of the computations. So let's start and do each of these steps. Again, it's good before you start to write a program to write such a structure of the program, putting your ideas in writing, so you will know how you want to solve a problem. So in our case, it's clear that we'll need some variables for counting, and these will be integers, count words, which will start with 0. Initially we don't have words. Count these, and again it will be 0. Count a, and will be 0. Count and will be 0. And I forgot one of them. Count and will be 0. So this will be the counting for our computations, and that's pretty much all the counting we want to do. Now we need to read the first token, and here we work with text, so what we read, what we keep will be strings. So let's read the first token, and to read we'll need to use a scanner. So we'll need to initialize the scanner um, like we did before, and we'll link it to system in. And now is the time. First, let's recognize these classes in Java util. And now is the time also to link, let's take the scanner next. Okay, to link this scanner to our file. So if we run first to appear in the run configuration, and we can go to the run configurations, and we have the work frequency, we go in common, input file, and we need to specify this text as the input file. So let's take this text. And sure, you can put any text. You can copy paste in this file what text you want, your preferred book. It can be a big text, doesn't matter. You will see how our program will be able to process such a text. Now, now we know that we'll do something. What I would like to do here is just to do first the minimum, so I can test that everything is glued together and works. So the minimum will be to have the while. So the minimum will have while token is not equals, and sure, I know how to check the equals to have not equals. So 1 hour token is not the end token, so you need to put a none here. We'll need to do several operations. And what we'll do for now, we'll just print on one line the token, and let's put here token. So we just identify from the text the tokens, and we'll write them one after another on the same line. Now, at the end, after we finish, we'll just need to close the scanner. And reading from a file, it's always good to close the scanner because it will close that file and you don't mess up with your operating system. Otherwise, you may have some troubles on some systems if you leave your file open. So let's see what our program is doing for now. And as you can see, it's reading and never ending. So we need to stop. You press here and terminate, force terminate the program, because we read it once and then we compare, but we don't go to the next token. That's why it's important at the end of the while to go always to the next token, because this way you know that you will continue the reading. Otherwise, we stay on the first token all the time. And sure, we already have the variable declared, we just read the next token here. So let's run it again. And as you can see, it's done. So these are the tokens that are read. And you can imagine that these tokens are not exactly words as I want to compare. You see, some of them are having some characters. Others, for instance, the start with the uppercase letter. That's harder to compare if we have all these tokens. I would like from the token to extract a word, and a word that will be the same independently of how capitalization I use or other things that I use. So what we do here in the prepare of the word, we like to create a word that will be like the token, but always after processing, for instance, always will be the same like lowercase the. So so we want to get rid of all the variants. So I will start with a token, and what I'll do first is to convert to lowercases. So if it was the beginning of a title or something, I will convert to lowercases, so my entire word will contain only lowercases. And this is one operation that I do to prepare the word. I go in lowercase. Now I see that some words are having at the end some characters like comma, dot. That's what we ensure will not be comprehensive here. We'll just do some kind of processing. Some others will not work. Here I have a parenthesis that I may not want to keep. Sometimes you may have something in parentheses and so on. So I have an and symbol that might not be a letter. And what I want to do is to get rid of it as long as at the end I have something that is not a letter or a digit. So that's what we like to do. Now, in this case, I have a single one, but theoretically you can have two symbols that will end like here. You see, you have both a dot and a parenthesis. So in this case, what we like to do is to get rid of both of them, not only of one of them. So basically, what we want to do is to check the end of the word and to identify where my word really ends, where I have a letter or a number that will be the end of my word. So let's try to write a small program that will just do this. So let's look at my word and try to see if I have something that is not a letter or a word on the last position. What I need to do is to take that character out of my word. So while my last letter, and let's see how we identify the last letter, we'll need to take the char last character um, in my word, and here we need to specify, okay, which is the length of my word -1, because this is a position of my character. And we have various ways to do this. How we check that it's a given character or not. So what we can do is to just check what characters we'll trim, and that's a good strategy, because then we'll know, okay, if it's a dot, I want to be trimmed. If it's um, if it's a comma, I want to be trimmed. Or if it's a parentheses, close parentheses, I want to be trimmed, and so on. So we can have manually identify which are the characters that I want to trim, to take out of my word. And then if I find such a situation, my word will become a substring that will start from 0 and will stop on the last character. So basically I reduce the size of my word without this character. And also it shows that we may have some, rarely we may have some things to trim at the beginning, like the open parenthesis here. I think this is the only thing that appears at the beginning, at least in this text. Let's do only for this situation. And it's easier because I know always which is the character at the beginning. I have word char at 0. You remember the index 0 is a magic index in Java. Everything starts at 0. And now what I need to do is to trim the first character. So I will start from the first for the second, which is with index 1. my word. So right now we hope to have the word correctly computed. So let's print whatever we succeed in. Maybe we did, maybe not. Let's see how good we were and print the word that we computed. Okay, so we have token chapter, word chapter, token forward for. As you can see, it's pretty much a good conversion. So let's look at some that needs to be trimmed here. Time point time. So our program seems to work pretty well. So here, instead of having in parentheses, we have the word without parentheses and so on. So we like it. It's working pretty well, and everything seems to be trimmed correctly. So now that we have the word, we can start to process this word. We can start to do our processing. So first of all, I want to increase the number of words because I find a new one. Then I need to check if it's any one of the words that I want to count. So the, a, n, and if it is, then I need to increase the count for that particular token. So here I'll need to increase count the plus plus and so on. So we'll repeat this one for all the text that I want to put. I have a and here I'll have a and so this will count all these statistics, and now we are ready to print the computed counts. Sure, we'll still have frequency to do, but let's compute number of words, and here I will have count words, and then I will repeat this one, and let's do it first. Number of the, and I'm using the other codes, so I will not I have a double code here. Number of the I can put also this part. If you want to put codes in codes, you need to escape them. This symbol escapes the code, so it will be a character. It will not close the code. So that's something that it's important for you to know. So let's take the number of this here, and then I will copy this for all the other things that we counted, like a and and we'll put the corresponding counters for each of them. So now we are ready to run the program. Let's run the program and see if we count correctly. And as you can see, I have 196 words, and in those I have 17 Z's, 9 A, 2 N, and 9 N. So pretty good numbers. Now also I want to compute the frequency, and sure, it's not so complicated to do because we have the elements to do it, and we'll have frequency of the, and the natural thing that you will do, oh, I have the count of the, and then I need to divide with count of words, but that's not quite good, because if I do that, I will get 0. for all of them. And I will get 0 because these, let's try this, and you will see the big zeros that we'll get. And this happens because the division frequency of z, and here I want to put frequency of z. So this happens because the division here will be the integer division, and dividing with a big number, it will always be 0. So let's run it, and as I said, frequency of z will be 0, which is clearly not correct. So what we need to force this one to be a double. Both of these are integers. So this is a number, an integer number, a whole number, this is a whole number. Dividing two whole numbers, this will be counted as integer division. So it will be a quotient and a remainder. And here the main problem is that 17 divided by 196 is 0. And remainder is 17. So we need to force to compute, count the or one of them as a double. So we have two choices here. One choice is to force by just multiplying with a double, and this will convert this to a double, so I will get a double result. So this is one choice. It's not the most elegant one, but this will work. You see the frequency, now I got 0.086 and so on. Now if I want to express it as a percent, I need to multiply by 100. So many times we'll just do that, we'll multiply by 100, and then we'll get it as a frequency as a percent. So its frequency is 8%. And when we print, if we want to show that, oh, this is indeed a percent, let's put the sign at the end so everybody will see it as a percent. So you see, frequency of the is 8.6%. So it's a pretty high frequency if you think of a text. Now, we can also take out these parentheses. They are not needed because the multiplication and division are done from left to right. They have the same priority, and it's enough to have one of them converting the result in double, and everything will remain double after that. Now, we did the frequency for Z. Let's do the frequency for all the others. It's very similar. Okay, so we have for A, for N, and for AND. And sure, we'll need to use the corresponding variables and. And after that, we'll need to print them nicely in the results. So A and we'll need to print them here A and. So let's run now and see our final program, what is telling us. So let me make this bigger. So you can see I have all these tokens and words, and then I count them, 196 words. I have 17 these with a frequency of 8.67, 9 A's, 459, and so on. So that all our program is doing, but this shows you how you can process a text and start extracting information about the text. In cryptography and in many other compression and in many other things, such processing is very, very valuable to know how to do it.